have Dr. Darragh Murphy today, who is a passionate ecologist with over 15 years' experience in ecological research and environmental consultancy, and he is currently working as an environmental consultant with Flynn Furney Environmental Consultants. So we look forward to Darragh's talk on nature-based solutions for flood and water quality management. So over to you, Darragh. But before you kick off, any questions, put them in the Q&A box, please, and we'll take them after the talk. Over to you, Darragh. Thank you.
Okay, thanks very much. Thank you, Jim. So, yes, thank you for attending. Um, this is this talk is about nature-based solutions for primarily for flooding, but we can talk about water quality as well, and is largely based on my experience and the PhD research that I did between 2019 and 2024, 25-ish, on this topic. And I have since then been doing it with Flynn Furney Environmental Consultants and Revis Ecological Engineering, where they have for a long time been involved in nature-based solutions of various forms, but bit by bit we're starting to introduce some of these uh, projects on flood management. So we'll get into it as the talk goes on. So nature-based solutions are they're defined as solutions that are inspired by, supported by nature. Um, they can be cost effective and they can simultaneously provide environmental, social, economic benefits. Um, so it's quite a vague term, and I think it's important that when we're looking for employing these kind of features in an effective way, that we try to be quite specific about things. And as we see now, as it goes on, that like a lot of the findings that we've had in the research that I've done and other projects is that it can be really case specific whether or not these kind of features are going to work, and certain features will work better in some areas than others. But the overarching idea for natural flood management is that you wanted to protect downstream areas, urban areas in particular, from flooding by having a kind of a catchment scale, diffuse network of these features that can help to slow down the flow of water through a catchment, usually by roughening channels, by ruffling the flow paths. So the rough flow paths might be where it might be on the land where rain falls on a field or on a piece of land, and it flows over rough ground on its way to a watercourse. Once it gets to a watercourse, that watercourse can also be roughened with boulders and tree branches and, sinuosity, pools, riffles, all these kind of physical features that help to retain the water in the channel, slow it down as it moves downstream. And the other aspect of it then would be to enhance the storage available in the upper catchments. And it being nature-based, it's to do with reinstating these kind of natural physical and ecological features that help to hold water back in the system, but due to processes of reclamation of land for farming, urbanization of various kinds, a lot of those physical features that hold water back have been swapped for slippier features that I'll talk about in a moment. So these three pictures are from the catchment that I did my PhD work on. None of them are actual fields that I worked on themselves, but they're representative of the agricultural landscape in Ireland, where we have essentially monoculture fields, where you got, say, one species of grass, water moves uniformly over this kind of flattened landscape, and moves in from fields into drains which have been straightened. They might have been stream channels previously, which have their own winds and bends and vegetation and pools and riffles, little ponding areas where water moves faster or slower. But those drainage elements, those stream channels, have been straightened. Often this drainage is done on farmland, whereas the drains are dug very deep so they can access the groundwater and divert groundwater away from the fields before the groundwater will actually, get into the field itself. So it's all to improve agricultural productivity by having fields which are that have a kind of consistent moisture, consistent growth rates across the field, generally more easily managed. It's more easy to manage a field with straight edges than one with windy stream channel edges. So a lot of these drains are straightened to facilitate machine movement and so on. And then in terms of flood peaks, flood management, and water quality problems, when the rain falls, it rushes off the surface of those fields very, very quickly into the stream channels and flows right down. And then you have high levels of erosion. You have a highly sedimented system during high flow events. Nutrients get washed out of the channel banks, off of the land, off of farmyard drains, that kind of thing. So you get these big pulses of nutrients that can move down, especially at the start of flood events and in early year flood events, like in kind of September kind of time, September, October, after, maybe fields have been plowed, you got more bare soil, nutrients that would have built up in kind of drier parts of the catchment get washed out in the early autumn. So the nature-based solutions approach to managing these kind of systems would be to try and reinstate some of that roughness and reinstate some of the storage back into the system. So I have two little plots here at the top and the bottom, which are very much theoretical, like they're not derived from anything real, but they get this representation of a system that's highly modified with low roughness and low storage, where you get rainfall event triggering an increase in channel discharge. So water gets off the fields, gets into the stream channel, raises the water level, raises the channel discharge. And in a really slippy system with low storage, that channel discharge can become a very steep, quick spike. So you got your peak flow increasing very, very quickly. Whereas in a rougher catchment where there's storage all over the catchment, you've got ponding areas, you've got rough ground where water will sit before it's more slowly draining through the catchment. You can have this flatter curve that's longer with a lower flood peak and often a delayed flood peak because more of that, it takes longer for the bulk of that water to get down through the system and affect, a downstream area like a town, for example. So hypothetically, if you have a whole system that has become re-roughened and you put all the storage back into the system, you can have this reduced and delayed flood peak. Um, so importantly, in terms of flood mitigation for a town, if you can reduce that maximum flood peak, you're going to be reducing that maximum water level that the river is going to get to in a town, and ideally by reducing it to that extent, that river level it's not going to get over, the channel banks in the town and flood the town. And by delaying it sequentially across the system, by delaying the flood peak to different extents across the whole system, you might delay the overall flood peak. And the same volume of water will get down through the system. It'll just take longer because water will more gradually drain out of this roughened system. Um, so these four features that I have on the screen here, they are four of the tests that I ran during my PhD on this farm in Cork, Leeds Farm, to the north of Macroom. So by building four features, which are kind of off-the-shelf nature-based solutions for flooding and for water quality, off-the-shelf features, we installed them in this farm to see what can they do to flood peaks, what can they do to water quality, how can they be installed so that they can, mitigate flood peaks in this way that we've seen in the previous slides, improve water quality without, hindering the farming enterprise that there was already going on in the farm. So we had to make sure that we didn't take loads of space. We weren't giving fields over permanently as flood storage or water quality features. They were going to be used as flood storage features. We're just going to be storing flood waters during and slightly after the flood peak event. Thereafter, go back into regular grazing. And the other features weren't taking up any more space really than had already been there. We just wanted to subtly but mindfully change the way water was flowing so that you have better contact with, say, the ecological systems in the soil and in the stream bed, so you can get better turnover of nutrients, so you can get uptake of water quality problems, nutrients in the system. Slowing the flow, roughening the flow paths by storing in the land, by installing these leaky dams, which we can kind of go into details about all of these different features later on. if you like. But I'll just kind of focus now on this flood detention basin and how it worked. So the top left photo there is the stream channel that was along the kind of northern side of this field, and I made a gap in the field channel, the bank channel, and water would then leave the channel during a high flow event at a kind of prescribed level. There was a ledge here at the top of the sluice here, below which water would stay in the channel. Water level increases and it flows over the sluice and into the field, and it gets impounded then as it flows over to the field, at the bottom of the field by this bund, kind of a U-shaped bund at the bottom of the field that was just soil, topsoil that was kind of locally occurring, that we formed into a bund. It grassed up again, and then cattle were able to graze on it out of flood events. So flood event comes, gets stores behind this bund, and it flows out through these pipes back into the stream, downstream of the field, and then in between those flood events, cattle are back grazing in the field. Um, these little enclosures with the kind of sheep fencing, chicken fencing, were so that I could track the effect that this flooding was having on the grass growth in the field. And I took samples of water quality, samples of soil, grass samples, that kind of thing throughout this, say, 3 year period of kind of 15, 20 flood events, to see what they were doing to affect that flood peak, to possibly uptake some of the nutrients that were flowing through the system, and how they were able to achieve those things without hindering the farm productivity. So here's what it looked like. You have a rainfall event. You have upstream discharge. There was a water level recorder upstream of the field before the water got into the field. There was a downstream water level recorder to see what the water level was like during these flood events. Um, and then we have uh, a water level recorder within the field to see how high that water level is during these storm events, from which we could, like, I was able to calculate the storage volume of the whole field. So water gets in, it gets stored for a little bit. It gets stored for longer than the actual flood peak, and then gradually drains back into the stream channel, and the field dries out. Cattle go back to where they were, happily grazing. Um, so so yeah, so the idea is that by taking some of the water out of the channel during the right periods, during the right parcel of time during that flood event, storing it on the land, and then draining that water back into the channel beyond that flood peak period, you can get some localized, at least, flood attenuation. Um, so we can pick up on this later, but that's the concept. We can kind of pick up on it later. We can also pick up on this slide later, which is a kind of a summary of the various findings of these four features that we installed. But for now, I think, yeah, so I'll just go on to how some of these nature-based solutions are being applied on a bigger scale. So some of you may be familiar with REVIS, ecological engineering. So I work at Flynn Furney Environmental Consultants, but then I'm subcontracted into REVIS for a couple of these projects. So the REVIS have loads and loads of experience in various kinds of river management, reinstating some of these physical features into rivers, managing erosion, mitigating the effects of high flows, at a really amazingly broad scale, from small little fields to big towns and so on. So we've been brought onto this project in Freshford, County Kilkenny, with the Nore Rivers River Catchment Trust. So we're kind of at the early stages, hoping to get a report done now in the next couple of weeks to see what we might do to manage some of the flooding that is affecting Kilkenny, or at least what kind of nature-based solutions we can put into the catchment with the aim of mitigating some of the flooding. So Freshford is very severely affected by flooding. Right in the middle of the town, on the edges of the town, you have a couple of significant rivers and channels converging within Freshford. You've got the Nuena is the main river that flows through Freshford from the west of the town there, and importantly, that's a karst river, so that's fed by groundwater. So all winter long, that river will be really, really high, as all the water that's been falling since the summertime gradually fills up that reservoir underneath that aquifer underneath the ground, and then keeps the water levels really, really high at that part of the system. The Gartina then is another channel river that runs into Freshford from the northwest. And that's more typical. That's kind of a more typical catchment where you have the main bulk of the flow is derived just from rainfall, and from surface storage of water in the soil, and a couple of other minor streams then that come in from pretty steep areas that all surround Freshford. So it's kind of steep to the south, the west, and the north, making Freshford very vulnerable to these peak flows. And then to the east of Freshford, the Nuena joins the Nore, which flows into Kilkenny then a few miles down the road. So the whole catchment is, as we've seen, especially in the past couple of weeks, um, severely affected by flooding and constantly affected by the risk of flooding, the worry that they are going to get flooded. So something about this nature-based solutions approach to flood management is that the flooding is affecting a town. So the flood issue is affecting a localized area, but the solutions then, the nature-based solutions to this flooding are throughout the whole catchment, and it's kind of as far away from that affected area as you can get, so that you can maximize the space that you're utilizing to achieve the storage. So at the start of September, myself and a few people from Revis, we did a big tour around the catchment, especially all the area to the west of Freshford. We went along the Nuena, along the Cortina Hilla, drove around all the little roads, looked over bridges, walked through some fields to see how the water was flowing. Were there areas where it was moving too quickly? Was there areas where it was already flooding? Were there marshy areas? Were there severely drained areas? And then to having developed an idea of how the water was moving through as much of the catchment as we could figure, we've been thinking that since then about what could we do to alter those flow paths to slow water down in certain areas throughout the catchment. So we're kind of at the beginning of it, really, in terms of honing in on some of those localized areas, but I've been going through a few of them. So up at the top of the catchment here, this is about 7 kilometers upstream of Freshford. We have a severely scoured drainage channel running along a field. Coming off of this mountain, this Knockmannon Hill here, you've got these linear drains going down through the catchment, and this is pretty typical of any like agricultural catchment. Really, you have lots and lots of straight field margins, and very often those field margins are at least ephemerally wet drainage channels, right? So to keep those fields dry, there's a channel formed around the border of the field. Water flows through that instead of flowing on the field. So it's pretty typical across agricultural catchments that you see lots and lots and lots of straight lines, and the water is flowing through all those straight lines. So when the water moves too quickly, like it is coming off of this hill here, it scours all of these channel banks. It erodes channel banks, eats into fields, sends sediment downstream. Sediment it gets impounded behind weirs. It can create dead zones behind weirs. You're bringing lots of nutrients out of the system. You're eating into field margins, so you're losing soil, you're losing nutrients from the soil, because the water is moving too quickly there for those channels to handle it. So looking in on a couple of these areas, here are some ideas that we can kind of consider in terms of slowing the way that water flows down through the system. And by applying these kind of features throughout the whole catchment. So this part of the catchment here is about 10 square kilometers, but if we were able to adapt 100 square kilometers of a catchment, or a large amount of the catchment, you could see potentially some really big impacts on those flood peaks once they get down to a town like Freshford, where it's vulnerable to flooding. So some of the measures might include roughening up of these channel banks, and strengthening of those channel banks so that they're less likely to erode, roughening them so that those high flows are held back a little bit within those channels, diverting high flows out of the stream channels and storing them on the land behind bunds, like you saw in the earlier slides and the project in Cork. Um, so, water can be roughened, the flow of water can be roughened in the channels. At certain points, then water will be diverted out of the channels, especially when that water level gets too high. The erosive force on those channels will become too high. At that point, you can divert water out of the channels, store it on the land. It'll be flowing over a larger area. It'll be flowing more shallowly. You can put additional bunds into the land then to help to slow the flow, store the water on the land, and then get it back into the stream channel before you get to roads, for example. Areas which are already wet, like this area here, that's kind of the downstream part of that channel. You got this big rough ground area that has lots of willows and kind of marshy ground. That could be enhanced so that you can hold water more effectively. Um, and all the drains that are feeding into that, they go into this main channel of the Gartina Hill, this Baleen part of the catchment. You can slow the flow, store the flow before it reaches that main channel at all of these little kind of first, second order drains that go down through the system. And then as you get further down the system into Freshford, the channels get wider, the flow gets bigger. You're dealing with large, much higher discharges, and it gets more and more difficult to use these nature-based solutions, these which are made out of natural materials, made out of trees, made out of soil. Becomes much, much harder to affect those really high flows. The discharges get so high that will kind of blast out anything that isn't a traditional hard engineering feature. But if we're just targeting the first order streams and these overly straightened, overly deepened, and overly incised channels, um, there's a lot there at one's disposal. There's a lot of these channels that can be amended in this way. Um, so the flood peak will pass through the system. Fields where water has been stored, um, they'll be wet just for slightly longer than that flood peak. Which in Ireland, I know we're going through a really, really wet period now, and maybe these features aren't going to be appropriate uh, for holding all that flood water back in the system to save a town like Enniscorthy from getting flooded. Um, but in more moderate flood events, you're looking at about 6, 8, 10 hours really in those towns where the riverbanks are overflowing into the town. So if you're holding water back for, say, 12 hours, 24 hours in the upper parts of the catchment as much as possible, storing them in the fields, by the time that water gets back into the channel and has moved its way down the system, that main flood peak that's posing the main risk of flooding to a town downstream will have passed through the system. And you're on the falling limb of the flood event then by the time the water is released back into the system. But what you need is a lot of space and a lot of like landowner buy-in to do that. So that's a secondary problem, but probably the biggest problem. Here's another couple of projects that Revis have been involved in. I wasn't involved in this myself, but some of my colleagues sent me over these photos where you got the River Barra, Donegal. It's a very important salmon spawning habitat, but as you can see, the the river channel itself is very degraded. The channel banks themselves are falling in. There's lack of fencing along the channel banks, so you've got animals getting too close. You've got really high flows that are eroding the soft channel banks, and you've got substantial erosion. Say the upstream water is sending a lot of sand and gravels into the channel that are kind of overloading the channel and kind of disrupting the flow paths, especially for salmon and the kind of gravels that salmon would need to reproduce in. So they did a lot of work to um, understand the way that that river should have been flowing, grading back the banks so that when the water flow gets very, very high, that the water isn't just eating into the channels. It's able to ride up the edge of the channels along a boulder toe, along this geocore that would be plant this it's a teram, a geotextile that would line the banks, help to protect the banks, and also help for the establishment of willow and alder and grasses, other riparian plants to help to stabilize that channel bank and kind of reintroduce the kind of natural flow profiles and riffles and ponds, that kind of thing to that river. There's a project that we were involved in last year on a farm in Ballinadee near near Inishannon in Cork, where you there was a farmer's field that was becoming really it was there was flow coming off of a farmyard area, that was getting to a field and causing lots of poaching and erosion of the field, and the that area of the field is becoming kind of unmanageable, losing a lot of soil, losing a lot of nutrients, putting downstream areas at risk of pollution and so on. Um, and so we had about 200 meters to work with to mitigate that flow of water as it went across the surface of the field. Um, so like in this example, you've got nutrient rich water, right? Nutrient rich, you're adding X nutrients into the system that may not be able to get taken up by the grass, and the water has its own erosive force. So that's washing the good soil down out of the system. So we formed sediment traps and a number of filter beds then, so level horizontal beds that would sequentially help to retain the water, increase the retention time of that water on the soil so you get better uptake of nutrients, some flow control structures so that you're giving the water a wider area to back up within these little ponds, and then a grassy soil to do some polishing, I suppose, of the nutrients before we reach a final filter bed at the bottom of the field there. Um, so that's going really well. There's a UCC project that's they've kind of taken over this project now, looking at the water quality effects. So I don't have any results at the moment myself, but they are coming apparently. So that's kind of it. I appreciate I zipped through things, but I felt it better to leave time for questions rather than overemphasize certain slides. So in summary, generally, we can install individual nature-based solutions, these features. Um, we can install them locally. You can install them as a set, and they can have quite pronounced effects on the way the water flows and on water quality in those localized areas. Um, but of course, the land use that's going on, the terrain, the capacity of the soil to absorb more nutrients, absorb more water, they're all highly variable across various catchments. So wherever you are, you're going to face certain problems. That said, farmland can be quite homogeneous, so there might be some easy wins there. You can kind of preempt that water is going to flow in certain ways, that you'll have subsurface drainage, you'll have land drains, you'll have hedgerows, and all those things can be kind of included in the mix for where your water is going to go. And then in addition to that, you might have um, the odd little thing that might put a spanner in the works. But the farmland can be quite predictable in terms of how water is supposed to move across it. Um, and then importantly, say like if we're looking at installing these features to genuinely protect places from flooding. Um, I mean, I don't know if there's any real evidence out there that these features can stop a 1 in 100 year event, for example. But they can certainly mitigate short-lived, smaller spate flows, all of which contribute to channel bank erosion, all of which can bring trees down and cause the blocking of the eyes and bridges, which will down the line when the big flood comes, cause further problems. So by holding the water back in during the small events, which is more conceivable, which is probably easier to do with these kind of systems, we're probably going to be helping with the larger events as well. Probably get a better sense of how water is supposed to move through these systems. But then there have been no projects really which have employed these kind of features and done this kind of restoration of water courses at a scale where we can say that they don't work in the 100 year event. Um, and because of the worldwide ecological breakdown, the very obvious over modification of drainage channels of water courses in Ireland, we should be doing something to bring back some of that natural hydrology, that natural ecological processing of nutrients, the natural growth of plants and animals in these systems. But to actually get predictable, measurable flood mitigation, we should probably be taking a hybridized flood management approach where we have these nature-based solutions covering the upper part of a catchment, but also we have more traditional flood defenses just in case they don't work or that will be employed during the really, really big events that we can be more sure that our nature-based solutions features aren't going to protect towns from. Um, and then the fourth point I have here is that the effectiveness is dependent on scale. So you need a lot of space, you need a lot of storage for these small features to really take effect. But there's a lot of space out there, and that space is being taken up with over-modified channels and over-drained fields. And what we found on the project that I did was that the grass productivity, the field productivity, was not impaired by flooding. The flooding lasted no more than 3 days whenever there was a flood event. There was a couple of times during the dramatic parts of winter when it was flooded for a week or maybe a little bit more of a week, but everywhere was at that stage. All the catchment was flooded at that stage. And from plant physiology point of view, grass growth is not hindered until 5, 7 days after inundation. So you inundate a patch of grass for 2 weeks. That's when you start to see, well, from a week on, 10 days on in particular, you start to see atrophy of some of the plant structures, that kind of thing. But if we're trying to mitigate the flooding of a town, because the flood peak is 6 to 8 hours, we only need 24 hours, 12 hours really, of holding the water back in those fields in the upper parts of the catchment before the water can be put back into the system. So if you have, you know, landowner engagement and buy-in and understanding of how short-term localized flooding affects grass growth and affects farm productivity, then I think a lot of the battles might be over. Um, because I guess we are asking farmers to give over their land for these features a lot of the time. But a lot of the features are just marginal land or stream channels that farmers or landowners don't have interest in, except that they are effectively draining their land. Um, but the knowledge is out there in terms of how we can achieve this kind of level of landowner engagement and flood mitigation, and the various features that we can install can affect water quality in various ways, can improve spawning habitat in various ways, can improve bird habitat in various ways. So it's just a matter of putting the right measures in with the right understanding and the right group of people and money, I suppose. So thank you very much. I can just leave this up on the screen here. So there's Flynn Furney and Rivis, the two companies that I'm involved in. You can contact us through those if you like, and I am happy to take any questions. Thank you.
Right, Darragh, thanks a million for that. That was fabulous. That was really, really good. I love the photos. So
Thanks.
I'll run through the questions here now. Some of them are pretty technical and might be above me.
Okay.
That's not difficult. Um, so sorry. No. So Harry Mansfield has come in with the first question earlier on. He said, "Hi, Darragh. Those leaky dams you show that were used at Leeds Farm have an open underflow. Is that sized to a specific flow rate? And if these are modeled, how did you represent them in modeling software?"
Yeah. So they were the space underneath is to allow base flows to go through. So I set the level of those leaky dams so that at a kind of prescribed discharge that we had figured out as like the flood discharge, like the water level at which we're getting these kind of these flood events. It was at that point that the water would back up against those leaky dams and start to be held back by them. Um, was there another part to that question, Jim?
There
Oh,
was,
yes, the
if these
modeling.
are modeled.
The modeling. So it was. I just did just calculated the flow upstream and downstream of them, and so I just empirically measured the channel bank, the flow rates. We had water level recorders upstream and downstream of the system, so you can measure the discharge that way. And did a little bit of finagling with that, but I didn't do any modeling itself. Um, and just to pick up on those leaky dams, um, they were leaky dams seem to be the most regularly advocated nature-based solution for flooding. But in my opinion, they're probably the least effective and the most risky to put in because especially when you put leaky dams in to slow the flow and you don't want the adjoining fields to receive any of that flow. You don't want them to get flooded. When all of that flow in the channel is confined, within the channel and is backing up against the leaky dams, the erosive pressures around the edges of those leaky dams gets really, really severe. Um, Especially over the period as the water level is increasing and it's backing up behind the leaky dam. Um, so it's going to be scouring underneath until it's able to go over. So once it goes over, you're releasing some of that pressure on the leaky dam. But when it's backing up behind the leaky dam, it scours the stream bed, it scours around the edges of the leaky dam. So they're really frequently advocated. But in my research, my understanding of how these things are supposed to work, they should only be employed where you want to back water up in the channel such that it will move out of the channel and be directed onto an offline storage feature, a floodplain, for example. So if anybody wants to pick up the leaky dams topic, I'll rant about it. Okay.
Thanks, Tara. Thanks, Tara. I'll keep going. There's a lot of
Do
questions
sure,
here.
yeah, that's fine, yeah.
Harry Griffin's in, and he's asking, have OPW implemented nature-based solutions to date in their flood relief schemes? There's a lot in this question. Now, a lot of these questions are long. Is a major barrier to their implementation that it is particularly hard to cost these solutions, which I think you were alluding to there earlier on, compared to traditional engineering solutions, given the vast majority of cost will be in landowner agreements for sacrificial floodplains, which can be unpredictable. I think you tackled a lot of that
Mm.
in your summary there at the end, but if you want to just throw something in again there.
Okay, I'll pick up on this term sacrificial floodplain. Okay, so I think if uh how do I say? So in the study, the farm that I worked on mine, there was no sacrifice to the floodplain. There was no sacrifice to there was no land given over for flood management. The land was flooded behind the bund during a flood event, and then the water receded and the land went back to productivity. And the grass growth in the field was not changed by 3 years of flooding. Um, So farmers might need to be compensated some bit. They probably would be needed to be compensated some bit. But if you can construct those features in a way that you're not permanently sacrificing the land for flood management, then that's probably going to bring down that cost a good bit. Um, the cost, I mean, so no one's really done this at a large enough scale to see how much it really would cost compared to like a large scale traditional flood management feature like a dam or walls in a town, for example. So the cost is kind of unknown. Farmers, there's lots and lots of grants available to landowners through like the Farming for Water, EIP, and Acres and that kind of thing for modifying channel banks for reinstating ponds, temporary floodplains for modifying channel banks by putting riparian vegetation in that kind of stuff. So they can all have a flood management effect, and they're all granted already. Um, they're all quite new. This Farming for Water EIP is running for a few years, and like there isn't a whole lot of understanding out there of how these these kind of nature-based solutions, these features work in these flood events. But the knowledge is out there, so I feel that some of grants, those features that are available in those grants, they could be modified to give them a better flood management potential. Um, and then in other terms of the cost of it, like I mean, flood defenses are very expensive, and uh, I don't really know if it's correct that this nature-based solutions way of going about things, even though it can take over, it would be necessary to have a lot of land to do it. I don't know whether it actually would be a whole lot more expensive than traditional flood defense features. Uh, but maybe it would. I don't know. I don't know.
Okay. Thanks, Tara. I'm going
Mhm.
to there's a lot of questions in here, so I'm going to,
Mhm.
for the moment, limit it to one question per person, if I can manage that.
Yeah.
So I'm skipping there. Someone, Ezra McManaman, has asked what scale of catchments are these types of measures considered to be? I think you referred to it, but she's pointing out there, we're pointing out here that is it a field scale or maybe 1 to 5 square kilometers or large, or
Yeah.
10 to even 1,000 plus square kilometers, and mentions the Freshford example, 10 square
Mhm.
kilometers possibly.
Yeah.
Just
So Ezra and I have been on the phone the past few days.
Ah,
So
yes. Ah, you see,
he and I
yeah.
were talking a little bit earlier. So,
Ah,
so that example that I showed in the slide, that was that what was contained within that slide, where you've got the straight field drains. That was about 7 square kilometers. But the whole catchment was like kind of utilized in the same way, right? So if it, the I think the entire catchment for that river was maybe 30 or 40 square kilometers. Um, the lower part of the catchment, the channels might be too large. The main channels might be too large. The flows might be too high to actually put some of these measures in. But if you can get 20 square kilometers of the catchment amended with these various features, then that would probably achieve a lot of storage. But the individual features themselves, say those flood detention basins, would probably be installed at the field scale. Um, Ezra and I were talking earlier about the example in Clonakilty, where there's a really large bund on the edge of the town of Clonakilty that has a sluice gate in it that can be closed so that Clonakilty doesn't get flooded um, during certain events. Sluice gate is closed, and then all the land upstream behind this bund gets temporarily inundated by that floodwater. So that's not a nature-based solution, but that is still that's kind of the other end of the spectrum. So you're storing the land on a field, and your bund is built within that one field, and the water gets into the field and goes out again back into the stream channel at the simplest end of the spectrum. And then on the other side of the spectrum, you have a single bund flooding all these fields, which is probably highly effective in terms of flood management. Um, and it might be the way to go. Maybe it is the way to go, but it doesn't actually restore any of the ecological functioning, the hydrological functioning of the stream channels, which I think is something that we should also be trying to tackle.
okay. I'll
Yeah.
keep going, Dara.
Mhm.
As I said, I'm trying to skip people now with multiple questions, and I
Mhm.
can see you're consulting with Ezra. Ezra has a number of queries in, and probably there for a reason as well, in fairness. But
Mhm.
I'll,
Yeah,
because of time, I'll keep going. And things like this do get the attention from Madhu Krishna Murali. Hi, Dara, great presentation. That will get our attention. And yes, it was a great presentation.
thanks.
And my question was how important is consultation with farmers and landowners when dealing with these projects at scale, or how easy or difficulty have you found these consultations? I think you did allude to it earlier on, but I'd say you probably have some more to say about it.
Yeah, I mean, in terms of actually putting features on the land, I haven't dealt with that many farmers.
Mm,
Often the farmers who are, what do I say? There is a lot of willingness out there for these kind of things to get built. And once a farmer agrees for something to be built, in my experience, it hasn't been very difficult to get it done once they kind of agree. Um, but from the onset, I would like to emphasize that like these features can be built in a way that there's no sacrifice to the land, right? There's no sacrifice to the farmland. By flooding a piece of land for the right duration,
mm,
there's no reason to say that the soil quality is going to diminish or that the grass growth is going to be impaired and that kind of thing. The seasonality of these things is also a really important thing to consider. So, like flooding a field for a week in the summer is very different from flooding a field for a week in the wintertime in terms of grass production. So, the metabolic rates of in grass is very low in the wintertime. They're not really growing. So therefore, when you flood the land in the wintertime, it doesn't really affect the grass growth because they don't have high metabolic needs. Um, but if flooding land in the summertime, then the turnover of the nutrients and the oxygen and everything in the tissues of the grass is much higher. So um, the metabolic costs, the physiological costs, of the flooding grass are different in the summertime. So, but that's still only when you flood the grass for 7 days and over. That's when you start to see this metabolic change. Um, and then the other aspect then of landowner agreement and engagement is it's vital to know what the drainage is like on those fields. So I'm aware that there's been a lot of like scoping projects done on this kind of thing which has been derived from, GIS online mapping, where people are kind of surmising the way that water flows. But then, in my experience, you get to the ground and it looks like the water is flowing through the channel. You've got like, I don't know, you've got drains that are very obvious in various places, and then you got some hidden drains that are totally overgrown, and you need to walk the land to find them. Tile drainage, subsurface drainage is also really, really important. So like you might find a really good field to divert the water from the stream onto and store it on the field, but then the water just drops right down through field drainage. Um, and then that's mobilizing stored nutrients in the groundwater back into your system. So it's important to get landowners to kind of be there for like be along the way with all the conversations about how the system should work, but then get information from the landowners about how water moves in the land, like what kind of drainage they have, what they need the fields for. Is an area in permanent pasture or is this going to be in tillage? Does it need to be reseeded? All these kind of things. So like if you're flooding a field and there's a flow of water going from a stream over a field and you want to impound that water, but the land is used for tillage, then you're just rinsing off all of your good soil. You're sending soil and nutrients back down into the stream. So that would require a different set of measures than the ones that we've talked about here. So in order to target the right measures, you need to talk to the landowners about how the land is to be managed, And one example actually in Freshford is that there's a field that frequently gets flooded just on the edge of the town. It's kind of within the town, but it's like on the edge of the center of the town. And it might be an ideal field to allow to flood as a flood storage. But in its current state, it's used in tillage, and the soil is already very degraded because water tends to get onto the field anyway through flooding. So, like, it might be a really good place to hold water, but in its current state, it wouldn't work at all because it's just the soil is too degraded, it's too bare. It would cause a big quality problem if we did allow it to flood. Um, so there's lots of things to consider before these things can get instigated. And it probably goes in favor then of the traditional flood storage approach, where you're like, "Do you know what? Let's just confine all the water to the channel, keep it behind walls, and then we're not going to be having to deal with all this really complicated stuff across a whole catchment of subsurface drainage and different land uses and all that kind of stuff." So I don't know, maybe that's another way to go, I guess, but that's for someone else to advocate, I think.
Okay. There's a couple of questions here side by side. There's from Mike Balvergal and Ezra again. So I have
Hmm.
to take one, but I'll just combine them because there might be. We're asked, is there any statutory guidance or farm schemes to aid in convincing landowners? And then from Ezra as well, you know, for do large projects of this nature require planning permission or appropriate assessments?
Yeah, I think, well, the plan permission, I'm not sure.
Mm,
Um, for it to be done on a really large scale, I presume there would be planning permission. Then again, I don't know enough about planning permission to be saying a whole lot about it. But in terms of the fields that I've worked on, there's no permanent change to the land use. We're not turning this field into a flood storage area. It's just holding water for a little bit, and then it's going back to being a regularly productive field. Appropriate assessments would probably need to be done for some of the larger schemes, but they probably screen out on if a nearby designated site, like an SAC or an SPA is going to be affected. Um, so that can be done. Appropriate assessment. It's important to consider all of um, the land uses and the habitats that are in a system. Um, and something Ezra and I were talking about earlier as well is that like in order for those kind of documents to go through the due process, you need someone on the other end who adequately understands and can sign off on the implementation of those projects. So that may not be there yet either, but it I think you kind of need to be optimistic about it. And then in terms of I did mention earlier about like the water farming for water, waters of life, acres, grants, like a lot of them are to do with water storage. And some of them are like, putting wetlands back into farms. So you got like a nice little wetland pond. There are some drainage, it's like flood detention bunds, I think, in the Waters for Life program. There's definitely riparian planting. So, like I said earlier, there's grants available for a lot of those features. They may not be in their current state the most effective for flood management because a lot of them are biodiversity management, but they can be amended to have a better flood management potential. Um, but I would also mention that like it's important to kind of not to conflate some of these features, like the biodiversity management features and flood management features probably need to be kept separate because like for if you're storing water on the land, you do want that field to be pretty dry outside of flood events so that you're maximizing the storage then available when the water does come in during a flood event. But to have a wetland, it needs to be permanently wet. So wetlands are not inherently good at storing water. They'd be good in the summertime when they'd be drier and the ground would be rougher and that kind of thing. So if you had a whole catchment that's full of wetlands, they'd be very, very good for flood storage and for especially during the summer. And it would definitely increase the roughness of the hydrological system, but actual volumetric storage may not be as good. But all of these things are available, I think, to an extent, and I don't really see why they couldn't become more available in the future. But I think the advocacy um, needs to have good information behind it, good understanding about how these systems work, you know.
Okay, so
Okay.
you're flying. Um, we won't get through all the questions. Apologies for this before we
That's
are going
okay.
to shut this off at 2 o'clock. But
Yeah,
there's
yeah.
3 or 4 questions in there about fish migration
Yeah.
and the Inland Fisheries Barrier Mitigation Program. Are you aware
Hmm.
of that and how does it affect and that's how much do we consider fish migration in these systems?
Yeah. So if you're directing water out of a channel and storing it in the field, you'd probably want to just include in your feature a way for the fish to get back out into the stream. And that's all doable. You just build it in, you just build it in. We on my project, we can considered like putting a guard at the sluice to stop fish from getting into the field. Um, but then like it would have gotten full up with brash, it would have gotten blown out, it would have been hard to manage. So in the end, it was just easier to like ensure that the all the water effectively drained out of the field, that there was no standing water left in the field at the tail end of the ponding events where fish might get stranded, that the water was we I did dig some channels into the field to make sure that there were no localized ponding areas in the field. So it was one single pond with a single deep point through which all of the water drained back into the stream through a pipe. So yeah, like if that might be a barrier really to getting through some of the consultation processes. But I really think that it can be built in. I think you can build in these mitigations to ensure that fish aren't going to be harmed in these features. And like it is a natural component of hydrological systems as well that water gets out of the streams and gets impounded on the land. Um, I know that like a lot of fish will use really high flows to migrate upstream. So, maybe some of them will be preferentially affected, more severely affected by diverting water out of the land, out of the streams. Whereas other fish would be hiding during really high flows. So it's even less likely that when your field would be operating as this flood storage structure, that they'd be likely to get into the field. But there's definitely ways around it. The barrier mitigation thing, like from an ecological point of view, the barriers program, the IFA barriers program is great. Like the potential to restore the fish passage through these systems by removing redundant weirs would be brilliant. Um, I kind of touched on weirs earlier, like the sediment impoundments behind older weirs can be really substantial, and there could be loads and loads of sediment, nutrient-rich sediment, possibly even dead zones where you've got like methane from organic matter that's partially rotting underneath these impoundments that could be um, hindering aquatic life upstream of weirs. If we can reduce the flux of sediment through systems by getting them properly vegetated, by reducing the scour of channel banks through putting these features in. I think that would be good that would be that would kind of tie into and help some of this concerns around the barrier mitigation program. Because there is a risk that by removing these physical barriers that you get the slug of nutrients, the slug of sediment running down through the system, which would also be harmful. But it's like I said earlier, like when you get to the sites where you're trying to work on these features, the answers are there. Like you get there's going to be always going to be these little localized problems, but you have to come up with these little solutions to it as well. And there's so much know-how out there from the IFI and OBW about how these streams are supposed to how it's supposed to function, you know. Um,
Thanks,
yeah.
Darragh.
Okay.
There's a few couple of questions in there about costs. I don't know if we can actually. I don't know if you'll be able to. There was one particular from one from Michal who was asked about any idea of the cost of the work on the farm in Ballinadee. Like, it's a particular thing.
It
I
was
don't know if you have costs of
it
that,
was uh
and you may not
there was a
be
machine
able to give
there
it.
for a half a day because he was doing work on another part of the farm. He was
Okay,
just moving some land around. So there was a bulldozer and a track machine there, and they spent 6 hours building eight ponds um on the field. And I think it cost like I think 1,500 euro to 2,000 euro maybe. And then there was another 1 or 200 euro for the willow planting and
okay,
consultancy fees, I think.
okay,
So but that was all grant aided as well. That was all grant aided. Yeah.
okay. Brilliant.
So
Thanks, brilliant
it
for
was no
that.
cost to the farmer, yeah.
And is there much maintenance? There's a question here from Anonymous. Much maintenance required in these systems?
Yeah. Well, um yes, probably. Yeah, they would need to be
Mm,
maintained. It
mm,
depends what they're built out of. It depends on where they are. It
mm.
depends on how frequently the water is flowing through the systems, through the sluices and that kind of thing. So there would be maintenance.
Okay.
It'd just be another job to do on the farm, I think.
Okay, very good.
Hmm.
Listen, I'm going to start shutting us down. If that's all right.
Okay,
I can't take all the questions. In
that's
fairness, you've
great.
been brilliant, and you've asked and answered a lot of those questions even before they came up. In fairness,
Okay,
even
yeah.
particularly Darragh, all I can do from on behalf of the Cork region is thank you very much for your time and
Okay,
what you've done for us today. And we might get you again sometime, seeing as you
okay.
attract a big crowd.
Thanks, Jim. Okay, thanks very much.
All right. Thanks,
Okay,
everybody. Bye
cool.
bye.
Thank you. Bye.